to start talking?
Yeah, I'll start. So hi, everyone. Yeah, my name's Curran. Thank you for coming out. I want to kind of make this like a storytelling thing, where I'll tell some of the background of the project and how it got started and everything, and then lead up to the current state of it and what we're trying to do with it in Alpine, how it relates to the big data stuff, and then I'll open it up for more questions. So let's see. Before I learned about D3 at all, I was really into this idea of HTML5 Canvas. And I taught this class at MIT, and these are the examples from the class. And so like this is the sort of stuff that I was into. You know, I enjoyed tinkering around with graphics and fractals and things. And like, yeah, making this wave simulation. And then I had this internship at a company called Rapid7, which is a cybersecurity company in Cambridge, in Massachusetts. And I made this for them. This is the thing. This is the project that really forced me to learn D3. And this shows user logins to a corporate network, and the blue represents failed logins, like if somebody entered their password wrong. And this is a leaflet map with D3 pie charts and this bar chart, and you can zoom in on the map. And as you zoom, it filters the other charts based on where you're zoomed into. And like you can click on this bar chart, and that will filter the data in the other two views. And you can also do brushing in the time view. So it's like this, you know, multi-dimensional filtering sort of thing. And so this, I sort of hacked it together, you know. And I was using Backbone at the time, a JavaScript library for, you know, managing models that have stateful properties. And luckily, they allowed me to open source sort of the foundation of that system. This was about 2 years ago now. And this is essentially the first version of this Chiasm project. And this is based on Backbone. And this is like the fundamental idea of the project, that you have this configuration that drives this application at runtime. And you can invoke these various different plugins, you know, have multiple instances of these various plugins, and then interact with the configuration to do things like change the color. And so, yeah, if you change the configuration, it propagates to the runtime components. And if you interact with the runtime components, that also propagates back to the configuration. You can see the colors changing over there. And this is a leaflet integration as well. So this is really like the first iteration of Chiasm, like far before I joined Alpine. And so that was during my PhD, when I was doing my PhD at University of Massachusetts. And this is a prototype from my PhD work where I'm starting to integrate actual visualizations into this thing, like a line chart and a map, and figuring out how to like link properties together from different components. So like if I interact with this A thing, it changes the B thing down there. And then I found this recurring pattern through all these projects where like there was a backbone model, and I wanted to have some code execute that depends on a few properties on the backbone model. And the pattern was like all the properties need to be defined, and whenever any of the properties change, run some function that does something and maybe sets another property. And so I realized that's really all that I was using Backbone for. And so that's when I created this library called model.js around April 2014. And it's very similar to Backbone. It has functions like on and off, so you can listen for changes in properties on these models. But it has this function called when that really is derived from this field of functional reactive programming. There's a when operator in these different functional reactive programming libraries like RxJS and Bacon.js. So I just took that one little piece out of functional reactive programming and implemented it here. And so this is one example of what the API looks like. You can say like when these two properties are defined and when either of them change, run this function which computes the full name from the first name plus the last name. And so to see this like in an interactive example, you can put some names in here, like I don't know, Sally Smith, and then as I type, you see it changes. So it's like the standard data binding stuff that you see in like pretty much any web framework nowadays. And so a lot of frameworks, like after this point, it's like build a templating language based on this, and then a component framework. But I sort of stopped here. So model.js is just the model and this when function. And this when function is kind of special because you can chain these reactive functions together. So here's one example, like when x changes, update y, and then when y changes, update z. And you can represent this visually with this kind of a diagram. And these lambdas are these functions. And this fits really well with data visualizations. So this is the reactive, I don't even know what to call it, like the graph of data dependencies that you get when you make a bar chart in this style. And all these properties on the left are the properties that can be configured by the user at runtime. And then all these functions are like functions that depend on these properties, and then ultimately this function here is the one that renders the bars of the bar chart. This is how you can make a single visualization with this kind of a framework, but it's also really nice for having linked views where there's some property in one of these models which is associated with one of the visualizations, and then whenever that property changes, it updates something about the other visualizations. So here's one example of a scatter plot and a bar chart where you can brush on the scatter plot. And then, so this is the iris data set, like this famous machine learning data set where each point is a flower. And this is like sepal length and sepal width, like these two different measurements about the flowers. And based on these, you can categorize them into their species. And so what this is doing is as I brush, I'm defining a subset of the data, and that's getting fed into a function that aggregates based on the species, and then the bar chart is showing you the aggregated values for each species. And so this is like the first example that I got working, and I was so excited when this was working, like finally like two visualizations at the same time are like talking to each other. And that's kind of the beginning of this model.js thing. And let's see, here's another example that sort of builds on the previous one where I added some animations. So now if I brush, you see the bars move around like that, they sort of dance. And then there's an HTML table also implemented in the same way. So each one of these three visualizations, I'm considering a table of visualization too. Each one of these has a model.js model behind it, and then some HTML elements that are constructed dynamically based on the model and whatever data you pass into it. So yeah, like I sort of got really excited because I'm like, oh wow, I found a way to componentize visualizations. And so I tried to just take all these various D3 examples that are out there and make them into components. So here's one that's a stacked area chart. And this is just like a test program that randomly modifies different parameters just to make sure that it's updating properly. And here's a parallel coordinates that does the same thing. So it's like when I started learning D3, it's like I came across all these D3 examples, and they're all very much hard-coded to like one specific thing. Like the data, the fields in the data set are like right there in the same line of code that defines the actual visualization logic. And that just didn't feel right to me. I wanted to split those things apart, the logic of dealing with the data and dealing with the visualization. So that's what this approach really does. Here's the same thing with a force-directed graph. So yeah, this was all like during the time when I was working on my PhD. And this example is like sort of I think the most advanced example that uses model.js with visualizations. So this is showing population of all the different countries of the world. And there's a line chart here, and when you hover over the line chart, it filters the data used as input to the map based on that year. And also when you hover on the map, it highlights what has tooltips, and it highlights in the chart below, in the line chart, that particular country. So you can see that like China is the biggest country, and then the second one is India. That highlights there. And then as you zoom in on the map, that filters the input to the line chart on the bottom. So if you zoom into like this part of Africa, oh no, my face is in the way. But this is the Rwandan genocide, actually. You can see it in the data. So yeah, and there's a color legend also. And then let's see, here's another example with model.js from that time where it's like two scatter plots, two instances of the same scatter plot component connected together with a brush, where you can sort of zoom in to the scatter plot with the brush. And then that's about the time I I graduated, and then I came out here. I drove across the country and started this job at Alpine. And I continued to sort of tinker with pure model.js stuff. This is, and like I wanted to just solve all these different problems individually. So this is solving this problem of the scatter plot where you have these optionally configurable fields of the scatter plot. Because like a scatter plot in its most basic form is just X and Y, two columns of data feeding into the chart. But you could also encode more columns of the data set into the chart using size and color. So here's one variant that uses size, one variant that uses color, and another variant that uses both. So you can encode 2, 3, or 4 columns of data into the scatter plot like this. And so this is facilitated by this model.js approach, where if you don't have a color column defined, then it defaults to not using color to encode data at all. And I think this is a really useful property in reusable components. So let's see. There was this cool thing that came up, this SwissNex like data visualization competition, where so SwissNex is an organization that has this data set, Data Canvas Sense Your City API. So it's a RESTful API that you can query, and it gives you live updating temperature data from these different cities around the world. So this is like the first prototype I did where it queries their API and makes a line chart of the temperature in Geneva. So this is actually the current temperature in Geneva in Switzerland right now. And so I made different variants of this where like here's a line chart of these different cities right now. And so you can see like here's San Francisco, and the temperature went down because nighttime, night is falling. And there's a bar chart there. So far what I've talked about is not Chiasm at all. It's just model.js. And that is the foundation of this Chiasm project. So, Chiasm defines a way to make components that are reusable. And it's based on model.js. So each Chiasm component is really basically a constructor function that creates a model.js instance. And so here are the Chiasm examples, in the order that they were created. So like here's the basic starting point. And this is like, internally it's significantly different than the previous prototype, but functionally it's basically the same. Where you have, right, you can edit the configuration at runtime.
I have one question.
Yeah.
On the model.js.
Yeah, sure.
Before Chiasm?
Sure.
So, to make that interactive, does each chart register with the model.js option? How does model.js know to render both of them?
Sure, like this one? The brushing? You're asking about how does the brushing interact with the model.js?
Right, yeah. If you change values, it re-renders that particular chart.
Right. So, I mean, from the code perspective, it's like model.js is, you can treat, instances of model.js are pretty much like JavaScript objects where you can set values on their properties. But when you do, on certain properties, those when functions get invoked. Anything, you can have functions that listen for changes in certain properties. And so when I add the brush here, when I brush, it's just changing the, it's a property in here called brushed intervals, which it's like, the min-max of the place that you're brushed over. And it's just setting that property on the model. and there are certain functions set up to listen to changes in that property. And then when those functions get executed, it takes those ranges and sets it as the scale domain for the x and y of the other scatter plot. And then that's another property of the model that another function is listening to that does the re-rendering of the chart. And so that's the thing that's nice about model.js, is it lets you set up these reactive functions that just deal with one specific relationship between two things or three things. And then you can like combine these together into these chains. And so when you're writing the code, it's actually simple because each piece of logic is very self-contained. It's like when I brush, set this property, and when that property changes, set the property over there, and then when this property changes, re-render the chart. And all those things are defined separately. Yeah. And all the code is here. They're all on blocks.org.
When you move the brush around, it immediately renders. How do you make sure that it doesn't re-render too many times?
Oh yeah, that's a great question. How do you make sure it doesn't re-render too many times? So model.js is actually like throttled in a way. So like those when callbacks, if you change a property multiple times in one like control flow, in one tick of the JavaScript event loop, the execution of the listener is deferred until the next tick of the JavaScript event loop. So even if your code sets the value like 100 times in sequence, the model.js listener doesn't get executed. It only gets executed once for that whole set of changes. But I mean, in this case, every time the mouse event fires from the browser, it triggers this whole chain. Yeah.
Do you detect cycle?
No, if there's a cycle, it just has this infinite cycle. But since the updates are like they're across ticks of the JavaScript event loop, it's not really literally an infinite loop. It's like an infinite loop with these like delays in between. And so I've run into that where if you do have a cycle, it's like this sort of infinite loop thing that's like over time. So it's like you see it just spinning, but it doesn't like crash the browser, because it's not because it has that deferred execution of the callback. So here's a Chiasm example that has visualizations on the page. And this shows a bar chart and a line chart. And there's also another plugin for loading the CSV file and specifying the column types. So that's one of the goals of the project, is to like totally separate out the logic of loading the data from the logic of visualizing the data. So yeah, that's another example. And also based on the that Swissnex data API, here's basically the same example as before, but this is using Chiasm to do it. And there's some interactivity here. So when I hover, that slices the data, it filters the data that's used as input to the bar chart, and then the bar chart sorts based on the sorted order at that particular time. So you can see, like, yeah, San Francisco was the coldest of all these cities a couple hours ago, and then it became the hottest. And this version shows how you can toggle the editor on and off of the configuration. And if you like change the color of one of these things, it will update in both charts. So yeah, it's like each of these examples solves a particular problem. Like this one solves the problem of how do you have a shared color scale between visualizations. So there's one Chiasm component that just is responsible for having the configuration of the color scale. And then there's another Chiasm component called links, which is very generic. It's a data binding component that says like whenever a certain property of one component changes, set a value of another component to be that value when it changes. And here's another example where it has a cross-filter integration. So cross-filter is this awesome JavaScript library for multi-dimensional filtering that's really like highly optimized. And so what this is doing is it's pulling temperature data for each day going back in time. So like it fetches the data for today and then for yesterday, it keeps going back in time. And then there's brushing set up so that when I brush here, it it shows that slice of the data in this chart on the top. And then when I brush over here, it shows a different representation where it's temperature versus humidity. And if you show enough data in that chart, you can see that cities sort of form their own unique like fingerprint in this space of temperature versus humidity. I don't have a color legend here. Like, I haven't quite solved that problem yet, but so yeah, it's showing like incrementally more advanced things. So this actually has like 2 levels of cross filter in it. Here's an experiment that I did about dynamically changing the configuration. So the way that Chiasm is set up is that this configuration is not just the starting point. You can set it over and over again at runtime. So what this example is doing is it's loading these different files that contain different configurations, and it's just sort of cycling through them. And the way that Chiasm is set up is it only detects the changes in the configuration. It detects the changes in the configuration and then only propagates the changes through the system. So every time you set the configuration, it doesn't tear down everything and then rebuild everything. It just uses what's there, but then just executes the changes. And so this is showing, that same reusable scatter plot from before, just changing the configuration from just using XY to changing the default size and then changing the default color, and then using color to encode data, and then also using size to encode data. And
Use this for solving like canvas responsive kind of problems.
so like, you mean problems where you would need to use canvas rather than SVG?
Can you leverage the same capability for making a responsive design framework?
Yeah, that's a great question about responsive design. So like, here's one example that shows, if I open this in a new window, you can see that it resizes to the browser window. So unlike most of the D3 examples you see that have the size hard-coded as like the first couple lines, this, Chiasm has baked into it a layout plugin that responds to the browser resize. But the way that it works is it just scales the layout in X and Y, which is different from how something like Bootstrap handles the layout. Like with the Bootstrap grid layout, it has like, in big resolution, you put things side by side, but then as it gets smaller, it gets stacked vertically. And right now, Chiasm doesn't do that. I haven't really figured out. It doesn't address the problem of responsive design. So like, you can run this stuff on mobile devices and on tablets and on PCs, but it doesn't address the responsive design. Yeah, it definitely has potential to do that. Yeah, like it's a very generic system, right? It's like just taking plugins and instantiating them for you and propagating the configuration through to the runtime components. And so you can make components that do anything, basically. And so one thing I have been working on recently, it's not working yet, is to use Bootstrap and the responsive design thing to actually lay out visualizations.
Did you expose the flexibility of how, for example, you make it like a phone, what should be the one that will show up, B or C? And all the way to the actual data itself, you have a subset of data.
Yeah, subsample, right, if that's on mobile. Yeah, that's a great idea. I mean, how? Yeah.
So you have a notion of hierarchy in that.
No, that's a totally cool idea, and it's totally possible. Yeah, just have another component that detects what kind of system it is, and then propagates that through the system.
Because that's the challenge in a lot of this technology is code differently for different devices.
Right, and you have different code bases, right, for different devices. Yeah. So it's something that is like sort of there in the background, but I haven't quite addressed it completely. But I mean, it's definitely like a future direction for the project. Yeah. So a couple of weeks ago, I changed around the API with regard to how the DOM is handled. So a lot of details, but like now I finally feel like this is the place that I wanted to get to, where like there's a reasonably well-defined component framework, like a component API, so you can define your own components in a straightforward way and with really clean code and everything. So the examples after this that have a thick black border are the this particular version of the Chiasm APIs. It's like 0.2.0. But I think this is where some of the most interesting examples are, the most recent ones. So this is an example that takes a leaflet map and a D3 globe and puts them together on the same page and sets them up so that they're speaking the same language. So like when you pan on the map over here and zoom, the globe will update. And so if you move up and down, like the circle shows where you're looking at on the globe. And you can also move the globe and that will update the map. And so this is a demonstration of that data binding plugin, but for bidirectional data binding. So it's the links plugin, and this is like within the Chiasm project. Oh, actually, why don't I just show you the GitHub project at this point. Now you get a sense of the project. So like, I recently moved it over to the Chiasm project. You know, it used to be under my personal GitHub account, but now it's here. It's like more legitimate or something. So there's a bunch of examples and some explanation, and like, yeah, it's this runtime environment that instantiates components based on this configuration. Yeah, chiasm, the word itself, refers to a part of the human brain that connects the brain to the eyes. And so there's this metaphor where like it's connecting the visualization, the eyes, to these like data systems, which are the brain, you know. But under this organization in GitHub, this is where I want to sort of roll out the chiasm components that have stabilized enough. Like if they appear, if I've copied and pasted them like 3 or 4 times between different examples, they've like stabilized and I want to put them into their own repository. And so there's the chiasm layout plugin right here, which is the nested box plugin. It will compute the nested box structure and set the sizes of the various components based on the configuration of the boxes. And there's the Chiasm links plugin, which is this data binding thing where you can specify how certain properties get propagated from one component to another. And so this globe example is showcasing the bidirectional data binding in this plugin. So like the center point of the leaflet map is bound to the center point of the D3 globe. And so this one line right here, it's a little domain-specific language for data binding in this system. So like the one arrow means it's unidirectional data binding, and the two arrow this 2 arrow thing means it's both directions. No, the order doesn't matter. The order doesn't matter here. And this is another thing that can change at runtime too. So if you were to delete this, it would remove all the listeners at runtime. So yeah, that's the bar I wanted to set with this project. Everything in the configuration should be changeable at runtime, and everything that defines the state of the application should be in the configuration. And the sort of principle behind that is when the users interact with the system, they will be sort of implicitly changing the configuration at runtime, which is a JSON data structure that could be serialized, you know, saved out to a file or to a database. So as you interact with the visualization system, that state that you arrive at can be persisted, and then somebody else can open it up later and comment on it or like make their own derivative. That's the idea. Yeah.
Can you have your own visualization callable by a function added to that config so that when that thing changes, it calls your function if there is no chiasm component for it?
Well, whatever you have in Chiasm has to conform to the Chiasm component API, and which is demonstrated in this Chiasm boilerplate example. And so a friend of mine, Ian Johnson, the organizer of the D3 meetup, made this really awesome in-browser editor, and I've linked to it from here. So if you click this edit this example, you get this building blocks page, and this is where you can go to experiment. And like if you had a visualization, like some D3 code that you wanted to make into a Chiasm component, this is the place to start. And so this defines a simple colored rectangle component where when you click on it, it changes color. And in the code, I don't know if I should go into too much detail in the code, but the component itself is defined like this. You make a new Chiasm component, and this is another project within this Chiasm project organization, Chiasm component, right here. And it's actually a very simple wrapper around model.js with some specific extra stuff around the semantics of public properties. So if you want a property of your model to be configurable from the Chiasm configuration, it has to be declared as a public property, and it has to have a default value. That's because if you remove the property from the Chiasm configuration, it needs to know what value to set it back to when you remove the property from the configuration. So if you look at the Chiasm component implementation, it's very small. It just makes a model.js model, and it adds some functions around public properties. And public properties is just another property on the model called public properties that's an array of strings, and that's all. That's all it is. And then it also encapsulates some conventions around the DOM. So if you want to use SVG, you can call this init SVG, which just creates an SVG G element that you can add your stuff to. Otherwise, you can create a div. So like the leaflet example is creating a div and then putting the stuff inside of there. And the way that you invoke this is you say new Chiasm component, you give it the default values for the properties that you want configurable. In this case, it's using SVG, so it calls init SVG. And then it uses standard D3 stuff to append a rectangle to that SVG. And then it's using the model.js when function to say whenever the color changes, or when the color is first defined, set the color of the rectangle to be that color. And then there's a box property that gets set by the Chiasm layout plugin. And so that gets set dynamically, like if you resize the page, the box property will be updated for you. So this responds to that and updates the size of the rectangle. And then this one adds an event listener to the rectangle, so whenever you click it, it assigns the color to be a random color. And when this assignment happens, then the model.js machinery kicks in, and it triggers that other listener that actually sets the value of the color. And that's it. It's like 50 lines of code. And so this could be a starting point for taking some D3 example and moving the code into here, and then just sort of massaging it until it works. And then you'll have your component, and then when you want to use it, you just reference it in the Chiasm configuration.
Is there a chance that these layout component has this box that it listens to others connected to, that they'll have name conflicts between these components?
Yeah, so in the configuration, the question is about name conflicts. In the configuration, each instance of a component has a name associated with it. In the code, it's called an alias, the alias for the component. And that's like a variable name or an ID, and these need to be unique within the configuration. So yeah, there's a possibility that if you're writing your configuration, you name two things the same thing, there will be a conflict, and it won't work right. Yeah, so they have to be uniquely named.
My question was specific to on this my.when box, and you said, that's from the layout component.
Right.
Something else from a different component.
Yeah. I think that gets to a deeper point, which I'll discuss. So in this example, I wanted to recreate the model.js example from before, where there's linked brushing. And in order to get this to work, there needs to be some understanding of the structure, how to represent this box, right? Because the brush, the thing that listens for the brush, needs to express this box in the same language that can be understood by the scales of this other component. And so as there are more and more components, there needs to be a set of conventions established. And like the baseline convention is like, okay, there's a box property that's an object that has width and height. And in so far, each example sort of comes with its own new set of conventions. But I think as more and more plugins get created, these will become more and more clear. But let me show you some other examples. So here's one based on the Leaflet example that's a visualization of migrant deaths in the Mediterranean. So this is up to date. Bo is here. This is Bo Erickson. He made the original version of this. Actually, I linked to it over here. This is from a D3 hackathon that happened a couple weeks back. And I brought this data set, and I'm like, oh, I want to visualize this, and I haven't quite figured out how to do it. And so this is the original one that he made using D3. I don't know exactly how it works, but oh wow, that's beautiful. Some tooltips. So this was like my inspiration. I'm like, oh, this should be possible inside of Chiasm just by manipulating the configuration. And then it should be possible to map up this map to be visualizing any data set that has latitude, longitude, and some value, some numeric value. And so that's basically what I did, is I extended the leaflet component to be a bubble map component. Well, yeah, so as you zoom in and out, the size of the circle sort of stays constant, so you can sort of split them apart. The main problem with this visualization, it's like a fundamental visualization problem, is like that there are a lot of overlapping circles. And so this sort of stood out at me, and I'm like, what is this? As I keep zooming in, all the circles are at the same spot, and I don't know how many there are. But this is Lampedusa, the island of Lampedusa, where a lot of the migrants, I don't know why there's so much data at this point. Maybe that's where it gets reported or something.
So the tooltip's still active, and can you click on them now?
So the tooltips were in the other map by Bo.
That was the question I was kind of sitting on. So I was wondering, in Chiasm, visualization, are you able to then inject clickable URLs or any other kind of textual data than just the visualization tools?
Yeah, so the idea with Chiasm is that anything that's possible should be potentially wrappable as a component. So like this feature that he has added of tooltips should be possible. Yeah, it's definitely possible to add it to the component that defines this map visualization. I just haven't done it. But it's totally possible.
That information coming in with the data, so you don't just have to have scalar data information coming in with the components that Chiasm is mapping.
Right. Right, and that's another thing that comes back to convention. Like so far, all the different plugins use the same convention that D3 uses of representing a data table as an array of objects that's parsed from a CSV file. So like that's what this assumes as the input format. And there's also another like top-level Chiasm plugin for loading CSV data. And so, yeah, right.
You said you can add the tooltip into this.
Yeah.
Would that be the component would be the map plus tooltip, or the tooltip would be independent component and even dispatched to that tooltip component?
Yeah, this is another kind of a deep thing, like because there's so many things like that. Interaction techniques like brushing and tooltips and hovering. Like there's this D3 Voronoi overlay thing where like if you hover, it will tell you the closest point you're hovering to. And like these are all interaction techniques that ideally you would just be able to sort of inject into any D3 based component. But currently the way it works is the implementation techniques are implemented like vertically within the component. And so in order to get tooltips on this component, it's not like there would be another component that just does tooltips. Although that would be a really interesting direction to explore. I just don't know how to do that exactly. But it's like, to get it working, you would need to change this map component to have tooltips.
So you can inherit or use some way, extend this component.
Right. And the way this is done in the code actually is the map base layer is an exact copy of this component. But then there's another component called bubble map that creates an instance of the base map and then adds the markers on top. And so you could then extend that in the same way and add tooltips, I think.
Yeah, we want the tooltips to come with the data.
Yeah, I mean, the information that gets into the tooltip is from the data. Yeah, yeah. And so you'd have to have that also as a part of the configuration, like which fields map to the, get exposed in the tooltip.
I hear that we can bring in other non-Kaizen component into Kaizen
Right.
the other direction. For example, I'm using Angular.
Oh, yeah.
How do you think about that problem?
Yeah, I've thought about that. And I haven't done it yet, but it should be possible for you to take any Angular component and wrap it up as a Chiasm component, and vice versa. Take a Chiasm component and wrap it up as an Angular component, because all you need to do is really map up the model layer for these two libraries. And so it's like Angular has its own internal way of dealing with the model state, which is very similar to this, actually. There's the scope thing that has like these properties, and you can listen for changes. So it's like you'd have to set it up to maybe have a whitelisted set of properties where you set up the appropriate listeners on the Angular scope thing or something like that. Yeah, it's just theoretically possible. And like if you want to tackle that, I would love that. That'd be so cool to see all these different plugins as Angular components as well. And there is like there's one thing like on the GitHub project. There's been some collaboration with this guy Jason in Japan. Let me just pull it up. It's interesting. On the issues, there's been some discussion about the directions for the project, and I added this thing like I would love to be able to have an SVG download button where there's a button in the corner of the page where you can download an SVG file or PNG file of the image, and this person is like, I made this already as an Angular directive. And so if we could figure out a way to wrap up arbitrary Angular directives as Chiasm components, that would be amazing. And I think there's potential for that. It's like theoretically possible. And likewise for React components, that'd be sweet, if any React component could become a Chiasm component. And along the same vein, like there's D3, there's this awesome D3 list of all the awesome D3 libraries. This is an awesome page. And there's like a lot of different libraries, and conceivably all the various visualizations from these libraries could be wrapped up as Chiasm components. There's nothing stopping you. And this is a direction I would like to go, is because like there's a lot of great work that's been done already, and it's not exactly like maybe the axes are styled differently or whatever, but just to wrap these up as Chiasm components would be super cool. And then you could like, if you have a stock particular application with stock market data, you can just sort of drop this in and connect it with a leaflet map and have brushing between them. Like that's the kind of thing I want to enable. Should be possible to wrap up anything that's out there as a Chiasm plugin and then connect it all together. So let me show you a couple more examples. Here's an example of a plugin that just renders images, but these are special images. They're from a paper from 1984 about data visualization and perception. And like this paper basically argued that bar charts are way better than pie charts because you can compare the differences. Like if you were to ask somebody, is A or B bigger in the pie chart? It's really hard to say, right? But in the bar chart, it's very clear. But these, like, it's amazing. From 1984, these are the visualizations that were being thought about. And still today, these are like the most common ones. So this is like sort of the baseline for Chiasm. It should support all of these different visualizations. So here's an example where just the core pieces of these visualizations, without the axes, are implemented as Chiasm plugins, drawing from the various D3 examples that make these visualizations already. So this is what I want to use as a base starting point for adding different interaction techniques like hovering or clicking, and also brushing and color, adding color legends, color scales. Yeah. And so, yeah, I'll just go through a couple more examples that are fairly new. This is focus plus context with brushing on an area chart. And this was cool. Like, I got it working without these lines in between. And then I'm like, well, with Chiasm, I could just make another plugin that just draws these two lines to connect the brush in the right way, you know? So you see these lines that are drawing in between. So I got it working. It works. And then this one shows a proper cross-filter integration in Chiasm. It takes a long time to load because it's a big data set. But it's basically a replication of the original cross-filter demo that shows this airline data. Here we go. And so, yeah, you can brush, and this does multi-dimensional filtering. It's usually snappier. I think it's because I'm recording. But it basically works, and it's like pretty much the equivalent of the cross-filter example from the cross-filter site. But the code is a lot more decoupled. Like in that example, I don't know, has anybody struggled through that one piece, that one example? It's like sort of a nightmare because it's like so cryptic and optimized. But like what I did is sort of extracted the essence of that. So now there's a Chiasm plugin for cross-filter, and you should be able to connect that to any visualization. So rather than bar charts, these could be pie charts or maps or anything like that. And you can have this multi-dimensional filtering feature. So, any questions so far?
The Leaflet period, does it do any downsampling, or like in this scenario where it took a long time to load?
Yeah.
Is it the server's responsibility to give you the smaller data set? Or?
Right. It is. It's the server's responsibility to do any data reduction. And that's actually, yeah, something I would like to talk about. So Chiasm itself is purely on the client side, but it's designed in a certain way so that you can make your own backend that is like a service behind the data. So like this is a diagram that shows sort of what we're working on internally at Alpine, where there's a full data set that is maybe terabytes. You know, it's huge, right? It's big data, and it's on a Hadoop cluster, maybe using HDFS to store the data. And this was inspired by a paper about the system Immens for big data visualization, and they have a section where they do an overview of different data reduction techniques. And that really resonated with me. That was like my inspiration. I'm like, okay, these are the data reduction techniques that really make sense. And it was like sampling. You can take a random sample of the data to reduce its size. You can filter, like only look at certain ranges of certain fields to reduce the data, and you can aggregate. And the paper was arguing that aggregation is like the most universally effective thing. Like if you have a column of data that's categorical, you can aggregate over the columns and have a much smaller data set, but it will show the distribution for the original data set. And also like histograms will show the distribution, but it's only representing a few bars, not the like billions of points that originally go into it. And like just fundamentally, I think it's worth saying that you can't visualize big data directly. I mean, you can try. You can like force the technology to get it to work, but ultimately there's only a limited number of pixels on the screen that you can see, right? So you have to reduce the data somehow before you visualize it. But you want to preserve the essential features of the data, like the distribution. And so this is sort of the system we're working on, where the server side, in using Spark, will do filtering and sampling, and then it will pass it to the client that will do more filtering and aggregation interactively, like the cross-filter example. And what we really want to achieve is this feedback loop, where the user ultimately gets access to the full data set, but through this kind of a system where the data gets reduced and then fed into the Chiasm runtime environment. The user perceives that visualization and then takes some action to change the representation of what they're seeing. And then you have this feedback cycle of like insight generation. You know, that's the idea. And we had like two variants of this system that we were considering. And there's pros and cons to each. So like the first system is like filtering and aggregation happens on the server side over the complete data set. And so what happens in this scenario is you visualize the small data, and then when the user interacts with the system, changes the column that they want to visualize, or like zooming in or something like that, that will trigger a complete, a new job that has to iterate over all the data and do the reduction, which may take a long time, right? So the downside of this is it's slow iterations. It's a slow cycle of iteration. But the good thing about this is it's very accurate, which is good for like reports that like you're going to print it into a document and it's going to last forever. It has to be accurate. But the use case that we were going for is more like using the visualization system to explore the data. Maybe you don't know about the data. Maybe you're looking at the data set for the first time. So this is the second approach, where the server will essentially take a random sample of the data set, and then on the client side, the filtering and aggregation will take place. And then that feedback loop of interacting with the data will all be localized in the browser. And so the advantage of this is it's faster, faster iterations. But the disadvantage is it's just estimates of the so let's say you had a bar chart that showed the total count of something. That count will not be quite exactly accurate. And we were going back and forth, like, should we show the count of the sample, or should we try to estimate the total count based on the sample? And we're not quite sure what the best approach is. But we think so. This is the approach that we're really pursuing, because we think that fast iteration is more valuable in that exploration process.
If you look into this identifying the visualization technology out there, because they are, for example, like data wash panels, they are very good at real time.
Yeah, and I saw Zoom data is doing something very, very similar, where they have like a rough estimation right away, but then it gets refined over time, and it's like in a streaming way. And there's another thing, BlinkDB, I think, that Chester was excited about at some point. That's a cool new technology that does basically the same thing. Like you give it a query, and it gives you an estimate of the results, but then it refines the results over time. So yeah, we're looking into those technologies too. It would be really cool to integrate with those, but it would also be a lot of work, a lot of extra work.
Yeah, I mean, how do you guys see yourself, I guess, product differentiating from that? I guess because it's quite a lot of competitors.
Yeah, there is quite a lot of overlap. I think the differentiation, I mean, maybe others could speak more, better than I could, but I think the differentiation of the Alpine product is really the big analytics, which I haven't talked about at all, which is like part of the core Alpine product. There's this visual data flow editor where you can, make data science workflows with various operators that scale to big data, and they have Spark implementations. And there's a collaboration framework around that, and that's sort of the context of this project. We're trying to add these visualizations into this environment. Anybody want to add anything?
In the long-term plan, we're talking about these different versions. We'll probably be doing both because both actually have a home within Alpine.
Yeah, they do.
What we want people to do is we want people to take their random data set, do this sort of exploration, this quick exploration, let's figure out interesting information about it. And once you get to that point, okay, now I understand my data, now I know what I want to do with it. At which point then you're going to be doing sort of the slower, this is the manipulation I want to do, this is the modeling I want to do. And at that point, this is the report that I want to generate, this is the information that I want to everyone else. So, yeah.
Yeah, definitely. And ideally, we would have a system where it's just a flick of a switch to switch between these two different modes, depending on what you want. And it should be like the same experience, basically, but with the not like, you know what I mean? The user should be able to just switch between these two different modes seamlessly, and everything should work basically the same. So yeah, that's it. That's all I got. Thanks for coming out. I'm happy to answer more questions and have a discussion. Any other questions?
So to use Chiasm project, you could basically import some the JavaScript libraries and then provide a configuration and then
Yeah, exactly. You wrap up whatever JavaScript library you want to use as a Chiasm component, and then reference it in the configuration. That looks like this. You can say, this is how to basically use it. New instance of Chiasm, set up the plugins, and then set the configuration. And the configuration references the plugins. And then the environment, based on this configuration, will instantiate the plugin and configure it dynamically.
how do you provide data to it? Like,
How do you provide data to it? One example that might be good to look at is this one, where there is a plugin that does loading of CSV data. So if you look at the here it is, config. Right. So there's one plugin called Data Loader that loads a CSV file, and then once it's loaded, there's a data property that gets set on this component, and then the links component is responsible for saying whenever the data is loaded, pass it into the chart. But the chart, the configuration of the chart needs to match up with that data. So that's how the data loading part works. Yeah. And you can make more plugins to hook into different backends also. And that's what we're doing in Alpine. We're making a custom plugin that hooks into our Spark-based backend. Yeah.
So what license is this under?
Oh, it's under MIT license. Yep.
He asked me to say that.
Yeah, it's open, and I would love to get more people involved. So if you're at all excited about the project, like, I would love to hear from you, or like, if you have any ideas. Like, I created a Google group, but so far, like, I'm the only person there, I mean, there's some other people there, but nobody's posted anything. But there is a lot of activity around the issues. So if you have like feature requests or bug reports, feel free to make a new issue, or like if you have an idea, like, yeah, post it to the Google group. I'll be there. there's no messages, but it's just saying.
this now, the model.js, is that going to be continued to be developed and still use it, or is that not into this?
Oh yeah, so it's that's under its own separate repository under my personal GitHub, and has like a lot of stars. It's been around for a long time, and the Chiasm component module depends on this, and so model.js is really the only dependency of Chiasm, and it will continue to be. Yeah, I'll continue to maintain this. There are some performance improvements I want to get to in model.js, and that will make it so that there's no delay at all, like when you brush in the updates. Because right now, each update cycle, it executes on the next tick of the JavaScript event loop, but I think there could be some optimization there. So that's one thing in model.js that I would like to address at some point. Yeah.
Could you talk about, just thinking out loud, like problem coloring, especially when you mix and match different stuff? It's always very difficult to style it correctly.
Oh yeah. So like with color, there's a few different problems. There's the issue of like sharing a definition of a color scale, and right now I have it so that you can hand pick the colors like this. You can manipulate them, but there's a few really nice tools for generating color palettes, and it would be nice to have some integration with those. And I have thought about this idea of like automatically generating a set of colors based on the number of colors that you need. And so here's the approach that I tried. It's using this perceptually linear color scale and sampling points off of a circle in this perceptually linear color space. So I tried my hand at automatically picking N colors, but like if you actually use these colors, they're like a little jarring, So like there's something not quite right. Like maybe I should have a slider for the luminosity, because this is the LAB color space. It's perceptually linear, meaning the distance in this space is the distance that you perceive if you look at the color. And so, yeah, I wanted to add like a slider to make it brighter or darker, because maybe if you just made everything a little brighter, like pastel colors might work better. Is that sort of what you were asking about?
Um, Actually, I like this one. Not exactly. I am thinking more like just every time when I mix and match different third-party libraries.
So you mean it's the issue of like when you mix and match different libraries, they each come with their own unique like look and feel,
Yes, that's right.
and sometimes they don't match.
A lot of times.
Yeah, a lot of times they don't match, and that's one problem I would foresee if you were to try to like wrap all these different libraries as Chiasm components, because they all do come with their own look and feel. And one thing I would like to do in Chiasm is like have it so that all the complete visual picture that you see is based on the configuration. I don't want to have any external like CSS file that you need to load.
So you can you wipe them out and then literally fully control it.
Yeah, that's what I want to do. I want to eliminate the external CSS and have everything defined inside the configuration. That would right. It would be cool. So then you could make the look and feel like the fonts and the sizes and the colors of the tick marks should all be the same across the different visualization libraries. That's one thing I would like to enable. Definitely. Yeah. Right. Yeah. Exactly. And I have identified like that's totally something that this project is trying to solve. Yeah. Unifying libraries and making them look as though they're part of the same environment. Yeah. All right. Thanks a lot, everyone.